So the first way I'm going to do it is write it as a polynomial. Now, letter B is one that people struggle on year to year, so I'm doing that with you, and you're going to do letter A on your own, and we'll jump to the rest of the notes. Tomorrow you should be able to have time to finish this up, and on Friday and Monday you should be able to have time to work on your study guide. Yeah? What? What? All right. All right, here we go. So we're going to write this as a polynomial, so I'm going to write f of x is equal to, so notice we're dividing by x to the fifth. If you write each term is over x to the fifth, namely x squared over x to the fifth minus 4x over x to the fifth plus 1 over x to the fifth. So you can always break things up into fractions, right? Everybody agree that those are the same expressions? So what is x squared over x to the fifth? 1 over x to the third, or x to the negative third. Can I write it like that? All right, the next one. Four x to the negative fourth, because we have 4 x's left, right? It's going to be negative. Everybody agree then I have x to the negative fifth after that? So look, I wrote it as a polynomial. Okay, wrote it as a polynomial. Let's take the derivative of that polynomial. What's the derivative of x to the negative third? Yep, negative 3x to the negative 4. Then, plus 16x to the negative 5. Then what? Minus 5x to the... So if I write that without negative exponents, I would have negative 3 over x to the fourth plus 16 over x to the fifth minus 5 over x to the sixth. Everybody agreed? Okay, so my goal is to see if I use the quotient rule, do I end up with the same thing? Okay? So that's the polynomial option. Let's do the quotient option. See if you guys remember the quotient rule from yesterday. Do you remember what the quotient rule says? F prime times G, all divided by G squared. It looks bad, it's not that bad. Okay? We'll be practicing it over the course of the next month and a half, really. It's going to have applications in trigonometry, exponential functions, all over the place. So, we got this quotient rule here. F prime means the derivative of the top. What's the derivative of the top? 2x minus 4. Times, what does that mean? You just leave the bottom alone, right? So times x to the fifth. So I'm calling f the top, I'm calling g the bottom. Minus, what's g prime? What's the derivative of the bottom? 5x to the fourth. Times x squared minus 4x plus 1. All over what? X to the 10th. So I apologize, you're probably running out of room a little bit here. But as you kind of follow, if you just want to follow mine, if you want to write it down, that's fine. But let's just see if we can make that look like that. First thing I'm going to do is I'm going to distribute this x to the fifth all the way through. And notice I get 2x to the 6th minus 4x to the 5th. And that's going to be minus 5x to the 6th plus 20x to the 5th minus 5x to the 4th. All over x to the 10th. Are there any like terms we could combine there? What? Yeah, I've got this 2x to the 6th and negative 5x to the 6th. That's negative 3x to the 6th. So those are gone. I've got my negative 4x to the 5th and positive 20x to the 5th. That's positive 16x to the 5th. Those are gone. I've got minus 5x to the 4th. And that's all over x to the 10th. As you glance at it, folks, okay, is what I have in green, is that the same as what I have in blue? Yeah, if we factored what on the top? What's a common factor in the top? X to the 4th, and that would cancel out with something x to the 10th. What would we end up with in the denominator here? X to the 6th, which is what we have right here, isn't it? Okay, that's our x to the 6th. And it would be able to pull all the way through. I'll just rewrite this. I know you're running out of room, but I'll rewrite this just for the sake of seeing it. Negative 3x to the 6th over x to the 10th. And then 16x to the 5th over x to the 10th. And then 5x to the 4th over x to the 10th. So if you notice, how many cancel here? Leaving you with 4 on the bottom. Is that what I have up there? Yeah, it is. And I have 5 cancel here, so 6 over x to the 5th. And then here's 6 cancel, I get 5, or 4 cancel, leaving with x is 6 in the denominator, which is exactly what I have up there. 16, sorry about that. Sorry, everybody. Yep. So it works out. That one's a little bit more lengthy. This one's easier. Go ahead. Divide it out as a polynomial, and then use the quotient rule. Go ahead, see if you can get it to work. Okay, please pause and look here for your polynomial. If you divide each of these terms by x, does everybody agree you get 3x plus 1? Have I taken the derivative yet? No. When you take the derivative, you get 3. That's the polynomial. So now when you use the quotient rule, you should come up with 3 as well. We'll give you a minute or so to a couple minutes to work. All right, let's check out the quotient rule. Quotient rule says take the derivative of the top. What's the derivative of the top? 6x plus 1 times the bottom minus, what's the derivative of the bottom? 1. Isn't that nice? 1 times the top, which is 3x squared plus x, divided by what's in the denominator? The bottom squared, so x squared. So let's see if we can simplify that expression, and what should we come up with? We should come up with 3. 6x squared plus x minus 3x squared minus x, all over x squared. 6x squared and negative 3x squared make 3x squared. X and negative x make 0. Divide that by the x squared squareds go away, you get 3. So we had 2 ways of being able to come out with the derivative. All right, you guys are now ready to take the problem to a little bit different spot. Turn to your notes. Let's look at problem D. We're skipping C. First of all, would you use the product rule or the quotient rule in order to find this derivative? The product. We will not do any simplifying of the algebra, but we will actually perform the derivative. So I have f prime of x is equal to, I will call this f, I will call this g. Remember that the derivative is f prime g minus g prime f. Anybody, what is the derivative of 3? 0. What is the derivative of x to the 1/2? Okay, so I showed you that there's going to come a point where you're going to say the derivative of the square root of x is 1 over 2 roots of x. It's going to become second nature. We want to think of that as that 1 over 2 roots of x. So everybody okay with that first operation? Times what comes next? Yep. So just x cubed minus 2x plus 1. Plus, oh, I'm sorry, I wrote the product rule wrong. It's a plus for the product rule, minus for the quotient rule, sorry. Now what? Now what do I do? Derivative of the second function, derivative of g. What's the derivative of g? Minus 2. Good. Times what? Square root of x plus 3, the original function. Now, is it possible that we could combine some terms together? Impossible. We're not going to worry about that right now. We want to get you used to the order of operations of the quotient or of the product rule and the quotient rule. Okay, leave it. You good? Okay, flip it over. Look at F, excuse me. F, product rule or quotient rule? Quotient rule. All right, let's find the derivative. This one's pretty cool. What's the derivative of the top?
0.
Ooh, isn't that sweet? Times?
3x to the 4th.
Yeah. Can I just not write it because it's going to be 0? We all get that, right? Yeah. It's kind of nice. Minus what? Good. Times negative 3. All divided by the bottom squared. And we can just write it as that quantity squared. So let's just simplify the top a little bit. The top here I have 0 minus this thing times negative 3. So what should I multiply this by? 3. So everybody, here's something, I hope you're seeing this. For g prime f, does it matter if I write it as g prime f or f g prime? Multiplication is commutative, right? So I normally, in this situation, what I would have done is I would have said, well, let's just put the negative 3 first. So it would have been a positive 3 because those would have canceled, right? Yeah, to me, that's an easier way of viewing it in that situation. So then you can see in the top, we get a 36x cubed plus 12x minus 3 all over 3x to the 4th plus 2x squared minus x, that quantity squared. That's the derivative. And as soon as you're like, that's really ugly, then fine. Then go ahead and do the limit as h goes to 0 of f of x plus h minus f of x all over h. Could you imagine how challenging that would be? So although the quotient rule, power rule, you might be like, oh, it's still a little confusing. Heck of a lot better than doing that, right? Yeah, so we celebrate that. All right, AP exam is going to give you a problem like this, and you'll probably see a problem like this on your test. It says, find the following. Notice in the table, it says f of x and g of x for given values, and it says f prime and g prime. So it says, find the derivative of f minus g of 3. And what we've learned is you just take f prime of 3 minus g prime of 3. What, according to our table, is f prime of 3? Negative 2 minus g prime of 3 is negative 1. Negative 2 minus negative 1 is negative 1. You do B on your own. When you got it, you can look up and check. Are we all good? Okay, so let's look at what happens for letter C. Naturally, can you understand why people want to do f prime of 5 plus g prime of 5? Because that's what we did for addition and subtraction, right? But what we learned is you have to use the product rule, right? So we'll do the product rule. So that would be f prime of 5 times what? G of 5. Plus or minus plus g prime of 5 times f of 5. Excellent. So when you write it out like that in product rule form, now you can go in and grab your values. F prime of 5, I've got 3. G of 5, I've got to go over to the g of x column and I get 0. I like that. G prime of 5 is 1. And f of 5 is 6. So what is my result? 6. So what I just asked you, I've never seen this really on the AP exam or this, but I've definitely seen both of these too. Because people want to do what they would do for A and B. So instead, use the product rule, quotient rule. You try quotient rule on your own. Go. I've got 1 times 8 minus 0 times 3. Is that what you got for the top? That gives me 8. And the denominator is 64. So you should come out with 1/8. Any questions there? All right, we got 2 more types of problems. We got right equation for line, then we have the graphical representation. Good job. Way to hold on. Oh, we might not get through both. We'll do our best. Right equation for line tangent to curve at x equals 0. AP question right here. Question you're going to have on your test. 1/3 of people get it wrong. You want to get it right? Then let's focus, okay? Because I hate marking this one wrong for people, okay? Because it's totally doable. Right equation for line, curve x equals 0. X equals 0. What 2 things do you need in order to write an equation for a line? Slope and a point. What is the x value of our point? It is 0. How do we determine the y value of our point? We plug 0 in. You get 0 on the top, you get 2 on the bottom. So what would it be? 0. Is everybody okay with our coordinate? If we want to be able to find the slope of the line tangent, we just find a derivative. Can we find the derivative of that? Yep. Yeah, no big deal. What rule do we use? Quotient rule. Let's do it. Derivative of the top. 4 times the bottom. Excellent. Minus or plus? Minus times all over the AP exam is notorious for doing things like this. And right away, you're focused on the algebra. You don't need to worry about the algebra. Does it ask you to write in simplified form what the derivative is? Does it ask you to factor the end result? Does it ask you to combine like terms? No, the fact is, I know that this produces slope. This produces slope. So if I want to find the slope, I just have to plug in the x value. That's all I have to do. Let's plug in the x value and see if we can get our slope. In the top, I'm going to have 4 times what? 2 minus -1 times 0. Everybody agree with that? Because I get -1 here, I get 0 there. Divided by, what do you get when you plug in 0 at the bottom? You get 2 squared, 4. So on the top, you have what? 8. In the bottom, you have 4. So the slope is? So did I have to do a bunch of fancy-dancy algebra? No. I just am trying to come up with the slope. That's my goal. I can now write an equation for a line. Y is equal to 2x. Piece of cake, upside down. Last one for the day. Same thing, write an equation for a line. I need 2 things. I need a slope and I need my point. On your own, in the next minute, see if you can come up with the point. We got 0, 3. And the AP exam will do this to you. They will say, okay, all those are 0, all those are 0, so you just have 3 times 1. Does that work out nice? Works out really nice. So let's follow up with that. If I want to find the slope, I need to find a derivative. What rule do I have to use to find the derivative? Product. So you tell me f prime of x is equal to what? 4x cubed, 15x squared, minus 6. You go, Carter. All right, is that my derivative? No, we got a little bit more work, don't we? Got to write that next function of x squared minus x plus 1. Plus or minus? Plus. Then what? 2x minus 1. Then times the other guy. X. If you plug in 0 for x, look. This goes away and you're left with negative 6. This goes away, you're left with 1. This goes away, you're left with negative 1. And this goes away, you're left with 3. So negative 6 minus 3 is negative 9. Isn't that nice? True or false? This is the y-intercept of the line. True. If you were to graph it 0, 3, 1, 2, 3, that's the y-intercept, right? Yeah, so it's just y equals negative 9x plus 3. Done and done. That's that. Ready